just like that, we're live.
Hey, it's another episode of Code Corner with AMster and
The Brit.
The Brit. And it's Rex Manning Day. I'm just kidding. It's C# Day. Steve, you probably don't get Rex Manning Day.
No, that one went way over my head, as do most of the cultural references that you use.
It's an Empire Records, that movie that came out probably 2 decades ago. So very relevant reference to today.
All right.
Anyway, it's C# Day.
It is.
I know you're excited about it. Maybe the audience is too.
Yeah. Hello, everyone. Wow, look at all these comments streaming in. This is awesome.
Wow. Hey. Steve and I run this show called Code Corner, and we're here teaching you all about how to get started coding. And if you are not a beginner, we've also got a segment for you later in the show where we look in depth at a coding project. And today, Steve is graced us by taking the backmasking project that I worked on last time. I was going to say last week, but wow, fixing it. Not just fixing it, but putting it into what? Are you going to argue a better language too next, Steve? You're going to say that on the public internet, right?
I am biased, so yes.
Wow. Okay. Woo. We're going to get some comments there, maybe. Anyway, so if you didn't see us last time, we started the show off by going over Python. We did some variable work in Python. We talked a little bit about functions, and we messed around in the command line, got into the REPL, things like that. And then we went and looked at the serverless application I built for backmasking, which is an audio engineering technique where you take audio and reverse it. It's just, you have to have a special, you can't just call it reversed audio. You have to call it backmasking.
It has to have some strange name, right?
Yeah.
But yeah.
And really backmasking
into the origins of that term. But anyway,
I think it's more describing when you add that reversed audio into a song, right? Kind of hiding
the message in the song.
That's right. So that's what we did last time. If you're here for the first time, which probably many of you are, we're here to answer your questions all about coding. If you're just getting started coding, we've got, like I said, that beginner's corner to talk about the fundamentals of coding. And we've got project corner to work with some of the people that have been coding for a bit longer. What do you think, Steve? What should people expect watching the show?
Well, hopefully a lot of fun. As you try and educate me with your various cultural references.
Is the fun mandatory, Steve? Do we have to have fun?
You have to have fun, yes.
Okay.
Yes, the coding will continue until morale improves. So how to fix a memory leak for an app in C#? Well, it's a managed environment. No. I'm looking at the comments coming in.
Yeah, I see.
But we should probably also say, we start the show with some general chit-chat. Like, what have we been up to recently? Like, what have you been up to recently, Am? Apart from making my life heck.
I mean, that's my primary purpose in life. So if you're going to remove that, I haven't been up to much. No, only joking, of course. Yeah, I've been working a lot in TypeScript, actually. I'm finishing up we didn't do proper introductions of our job titles or anything like that.
We did not. Maybe we should do that first, and that might help educate people on what it is you've actually been doing.
Yeah, that's true. So I'm the developer advocate for a fun program at AWS called Game Day, AWS Game Day to be specific. Game Day is a big hands-on type of I'd say gamified workshop, but workshop is not even a great way to describe it because workshops are very linear, very step by step. This is completely, it's like an escape room almost, honestly. If you ever done an escape room, it's kind of like,
would choose your own adventure kind of be like that? I mean, there are certain guardrails, obviously, right? But within those guardrails, you are navigating a path, right?
Yes. A bit. It's kind of, I always use escape room it's like an escape room in an AWS account. Anyway, we got a bunch of tools for building these things. And I've been working on the TypeScript SDK. So TypeScript, Steve, should I talk a little bit about what that is in case?
Sure.
Anybody?
No, we
Okay.
have a bunch of people new to coding on here, so yeah.
Yeah, I see. We've got I'm a beginner in coding,
Mhm.
starting an
Welcome.
AWS journey, keen to learn more. Welcome everybody.
Yeah.
We also had a question about backmasking too. It's not for the acoustic echo cancellation. It's actually just taking a piece of audio and reversing it.
For
We'll
fun.
get to see it later, right?
Yeah.
Or to hide messages, right? Anyway, so TypeScript, it is a typed version of JavaScript, right? So it's taking all of what JavaScript can do and then adding strong types to that. And it's becoming, I think, a lot of people's preference for working with JavaScript, because some of the reasons that we saw in Python last time, right? Anything
Yeah, I mean, you and
can
I
be.
both worked in TypeScript, right? When we were working on some of the tooling at AWS, right? And I found it an easy thing to adopt because I was coming from a C# background, which is strongly typed, into JavaScript, which is not, and that was a bit of a hurdle for me. But TypeScript got me over that hurdle,
Look at
right?
this, Steve. I knew this would.
Yeah, PowerShell is more of a dynamic type system, as we'll see in a little while.
Yes.
But
Yeah, you've got some PowerShell today, don't you?
we're going to have a few snippets of PowerShell, yeah.
Okay. But yeah, so TypeScript, it just offers a couple things, but the primary purpose of TypeScript is to add in strongly typed types to the language so that you can't reassign a variable to, from a string to a number, for example. So we saw some of that in Python last week with the REPL, right? Where I could change a declared variable to a different type without Python complaining about it.
Right.
There are actually type annotations in Python now too. There's been a lot of work recently in the past few years adding in type annotations, so you can do similar things to what you do with TypeScript in Python as well.
Yeah, I actually enjoyed the time working in TypeScript. That was a lot of fun.
Yeah, that's what I've been up to a lot. What about you, Steve? What have you been up to?
Well, I've been out mostly at events. Obviously, events are beginning to kick off again. So I spent a week down in California a couple of weeks back, where we had Developer Week.
Okay.
Which is a very broad spectrum developer conference. It's not .NET specific, it's not Java specific. It's just a whole bunch of devs working in an expo booth and delivering sessions. That was a lot of fun. And in fact, what made it even more fun was in the last episode, right, when we were talking about languages.
Yeah.
And we had a lot of questions about what language should I learn, right? And we had a bit of a back and forth discussion about, well, from my recommendation, you should learn two. One is a scripting language like Python or whatever you feel like, Bash, I don't mind. The other one would be a strongly typed language like C# or Java, or maybe use TypeScript. Either way, but something that has typing in it, right?
Right.
And the exact same question came up at the booth. So on the first day of the conference, in the evening time, we had a whole bunch of students came in, which is just awesome. I spent a whole lot of time talking to this 3, 4, 5 students that stopped by the booth asking about modern development, cloud development. What language should I use? What's it like working in the IT industry? I don't know why they came to the Silverhead guy to ask about that particular question. But anyway.
They can't see my hair, so they don't know what color.
It was a lot of fun. And we had the exact same discussion about, don't focus on one language to the exclusion of all others. Pick a dynamic language, pick a strongly typed language, and then learn those, and then see which side of the fence you prefer. Maybe you like both. I'm happy working in both, and then go from there. So, but yeah, it was fun. So, and there's also been some other news that's come out in the .NET land. So we didn't not introduce me.
Yeah,
we did. So I'm going to introduce myself now. So I'm Steve. So I'm a developer advocate at AWS, but I focus on the .NET and PowerShell tech stack. So that's why we're doing .NET today, because it's my turn. So yeah, there's been some news out there. So if you want to bring up my screen, we got a new release this week.
Wait a minute.
How we doing? Sure. Well, see, this is the interesting. It's both. So Steve loves it, but also there are language benefits right? And performance benefits. It depends on what the answer to that question is. It depends, right?
That's the classic answer to every
the classic
question.
answer, right? It depends on what you're trying to achieve, right? I've always worked in a C#, C++, C kind of language domain. So Python to me is new. So I'm learning Python as part of this.
Yeah.
Or trying to ignore Python as part of this. I don't know which way I'm going to put it, but anyway, I'm learning something. It depends. But the thing is, in Code Corner, we're trying to be language agnostic, right? So yes, I'm going to use C# or PowerShell. AM is probably going to use Python or TypeScript. Maybe I'll convince him to use Java at some point. I don't know.
I'd probably be more likely to do some Go before Java.
We'll go, right? Yeah. So, it's a learning journey, right? We recognize that everybody is at different parts of that journey, right? We've been coding for, I don't know how many years, decades now, right? We've got people on the show who are just beginning, right? Which is where the what language should I start with, etc. discussion came from last time around. So we're trying to cover as many bases as we can. Obviously, we don't know every language out there. If I could find myself a COBOL compiler, I'd share some COBOL. But anyway, that's beside the point. That's where I started. But yeah, so back to news before we move on. So yeah, we've had some new releases in the .NET land that I wanted to highlight.
Sure, yeah.
You can bring up my screen.
You got it.
So the first one is this. This came out this week. This is literally hot off the presses. So this is a new set of libraries, extension libraries, if you're coding Lambda functions, which we're going to be doing later on in C# using .NET. And basically what this is, it takes away, I was going to say some of the grunge work, but it's not really grunge. It's basically attributing code, and we're going to see this later on. But there are 3 libraries, one for logging, one for metrics, one for tracing. And what you do is you basically can add the relevant package to your Lambda function project. You can set some variables, and then you can annotate your code. So you see this statement that says logging, right? That's going to inject logging support, calls to logging in CloudWatch logs from the Lambda function. So it's going to intercept all the logging output, send it to CloudWatch logs, but in a structured format. So I'm going to show you that one later on. So that came out literally this week. So this is the kind of example of a log you're going to get, a structured log. And when you get a structured log, what that means is then you can execute queries against those logs. They use like a SQL type language.
Nice.
So really, really useful for ops. There's also a bunch of metrics and other things inside this library. So I wanted to highlight that one to start with, because we're going to be taking a very quick look at that later on when I take your backmask function. I've already written it in C#, but I'm going to extend it to use our new annotations framework for Lambda, and I'm going to use the power tools as well.
I love it.
To show how it removes a lot of the boilerplate code.
We're getting still some comments about language too, about language choice. And I wanted to highlight this as there are lots of reasons to use languages, right?
Yeah.
Every language has strengths. Every language has weaknesses. I wanted JavaScript, for example, got a strength in your front end is going to use JavaScript and your back end application. So like the website view that people see, when that's what we refer to when we say front end, and then the back end is maybe a server, maybe a Lambda function, maybe API gateway fronting something else, right? So
but you can do the same thing in C#.
You can,
right?
but
we have a thing called Blazor, right? Blazor runs on the server, right? And renders pages from the server side, but you can also use it on the client side instead of using JavaScript.
Right.
You can actually write your code in C# on the front end. If you wanted to, right? If you wanted to stay in one particular language stack, maybe that's attractive. Maybe it's not. It depends again on what's your use case. What do you need it to do?
True. I saw another mention of cybersecurity and Python, which again, this is Python's very prevalent in the cybersecurity world. There's a lot of the tooling and a lot of the servers, already have Python installed that you're working with, like Linux servers in the cybersecurity world, typically. Machine learning, also another big place where Python kind of.
Well, that's where we got started on trying to teach me Python, right? Because we've done a whole load of AWS on Air segments at various events where there's been a lot of machine learning. Yeah. Right. And frankly, I'm out of my depth. I can read it, but I don't really understand it. Thank you, Carlos. Yay.
I thought I'd put that up there for you. And today, that's the language we're talking about. Is
we will be.
right?
Yep. So there's a couple of other things I wanted to bring to people's attention from .NET land, since it's kind of like my week. Is server-side rendering possible? Yes. Server-side rendering is possible. So my colleagues, so if you're working with Lambda functions in .NET, C#,
Which we
my
will
colleague,
be today.
Brian, which we'll be doing today, he's got a blog, No Dogma blog. We got a link to throw up on screen. So he posts quite frequently about Lambda and C#. So if you're into that, go check out this blog site. The other one that I wanted to bring to your attention, I don't have a page for this, is we have a new .NET on AWS show on Twitch. So it's streaming. I think the next episode is next week. March 10th. That'll be on Twitch. My colleague Isaac presents that. He has special guests on last week in the... Come on, AM, keep up.
Well, you still got the blog post up. So,
well, I don't have a page for the .NET show
for the
right
.NET
now.
show. Okay.
But he has so last week's inaugural episode, he had on my ex-colleague Norm, who I work with on the SDK and .NET tooling at AWS, and they were talking about the annotations framework that we're going to be showing today. Well, they were showing it from the perspective of let's write a brand new Lambda function using it, whereas what we're going to do today is take the existing project and then move it to the annotations framework and show how easy that is. Okay?
There's your .NET show. Yeah.
Yeah, that was the .NET show.
We had a comment come in. I did say Python's very popular in machine learning.
That's right.
Yes, yeah. Machine learning is a concept, but a lot of people utilize Python when working with machine learning because Python has a lot of bindings to C libraries, and those C libraries are helping you achieve machine learning through the frameworks like things like PyTorch, Keras, etc. Right? So Python is a very, very popular language for machine learning practitioners.
There's also ML.NET.
I was going to say
machine learning library, right? I've never used it, so I don't know how it compares to say using Python. Obviously, Python is probably more popular, I would say, but it is there. So, either way, you can't go wrong with either language, in my opinion. But
did you remove your screen?
Yes, I just took my screen off. That was the one bit of control I had.
Okay, I was wondering if that just happened. Anyway,
I wondered why I could hear cogs grinding from this distance.
I was like, wait, where'd the screen go? Python is not the only language for machine learning, as Steve just said. There's ML.NET.
Actually, is it Sharma says, can we do ML in C#? Yes, you can. There's a library called ML.NET.
Yeah. Oh yeah, there we go.
You can use to do that.
Are you
ML.NET? Here it is. Actually, I'll bring it up. Have you got it?
Yeah, I've got
there we go.
ML.NET.
There you go. So you can do it in C#. I've never done it. Maybe that's a future project that we could do on Code Corner. But yeah, it is possible.
All
okay.
Right. Cool. So that takes us to what, Beginner's Corner?
I think it's Beginner's Corner time.
All right. So let me throw up Beginner's Corner.
That's what we've got for graphics this time round. This is a low budget show.
Hey, I'm the graphic. All right. So Beginner's Corner. What is Beginner's Corner, Steve? What are we going to be doing today?
So Beginner's Corner is literally that. If you are at the beginning of learning to code using either scripting languages or statically typed languages like we're going to be showing today, we are starting from almost pretty much ground zero. We're not assuming any knowledge. So last time out, we started a discussion on variables because obviously when our code runs, we need somewhere to store values, right? We've either called something and we need to store that value, or we were using a temporary value in some code that we're running to do a computation, whatever, but we need somewhere to store it, right? So we went through showing how in Python, we work with variables, how we can assign numbers, strings, how we work with them in code, etc. So today we're going to be taking a look at the C# way of doing it, and what the difference is between strongly typed and dynamically typed languages.
All right. Very nice. We're getting some questions in from chat. Can I use Python libraries in C#? I think there is a it's called Iron Pie, I believe, that can run Python code.
Many
Is
years
that a
ago,
thing?
there was something called Iron Python
Yeah,
that I
Iron
think
Python.
Microsoft created, but I don't know what happened to it.
Still, I just Googled it. It's still here.
Still around? Okay.
Yeah.
I mean, .NET is a multi-language runtime, right? There's C#, F#, VB.NET. So there's also COBOL.NET for those so inclined. But I don't know what happened to Iron Python.
Yes. Yeah. So, I mean, I think some people are questioning why you're showing them C# today, Steve. So I didn't get this when we did Python. It's very interesting, but I'm sure you hear this all the time, especially as a dev advocate at AWS for C#, right? And .NET. You know, why C#? I'll ask what everybody. I'll summarize what
Why
you're
C#?
saying in chat. Why should I care about C#?
Do you want my personal opinion?
I want both your personal opinion and also, like, more practically, why is it a language that I should invest some time in?
So C# differs from my knowledge of Python right now, right? In that, from a personal opinion, C# is a very elegant language. It's into version 10, I think, right now.
You've got some support in chat.
I got some support here, right? It's actually a very elegant language. In fact, if you look at the Stack Overflow sort of language rankings that come out every year, it's pretty highly rated. It's a very nice language to code in. It has some really nice syntactic sugar that it has that avoids some of the boilerplate that you get with other languages.
Yeah.
But it's also a very, very performant language when it's compiled. No, I don't want to steer too much in towards Lambda and cold starts, because dynamic languages like JavaScript, Python are always going to launch faster in that environment than a compiled language that has to load a runtime, right? But once you've got over that launch, C# is actually one of the fastest of the Lambda runtimes when it absolutely blazes through it. So from my perspective, I came from, and I think we touched on this in the last episode, right? I started my coding career way back in college with BASIC, then Pascal, COBOL, then into C. Then my first few years as a developer, I worked in COBOL, writing COBOL developer tools in COBOL on IBM PCs at the time, right? Then moved into C, C++, C#, etc. So I've gone down that path that ultimately led to C#. I haven't strayed too far from that, in all honesty. I've done a little bit of assembler. I still like assembler. I just don't get to code in it these days. There's something about the mindset of it. But I think C# as a language is a good one to learn.
Yeah.
From the strongly typed, I want to work in an object-oriented, class type, I said already, environment. C# is one of the best, if not the best. I have not checked out things like Rust or Go. I don't know what they're like. Maybe I should.
Very different. Very different.
I'm guessing so, right?
Yes.
But yeah, I think just because a language is compiled isn't in this day and age isn't a reason to say, I'm not going to use that, right?
It's true.
There are benefits to it, right? So we covered on last time round, hey, you were able to just randomly assign a string to a variable that held a number, right? In some languages, that's an error.
It is at compile time and not runtime.
Right. So I'm going to catch that error at compile time, right? Not runtime. I don't want to deploy my code and then find I've got type errors at runtime, right? Ideally, that's my personal preference, right? Some people are just like, yeah, it's fine.
And there are ways to
duck and it quacks like a duck, then it's probably a duck, right? Yeah, there are places for that kind of thing, right?
And there are ways to achieve that with more dynamic typed language like Python and JavaScript, right? You've got TypeScript that we talked about earlier, and Python has type annotations too that you can, but they're not strictly enforced by the language like in C# or Java or other typed languages. I'm going to put this to chat too. If there's a language that we're not covering yet, tell us. We'd love to cover it. Look, my favorite language, this is what I say all the time, Steve. You get to hear it again. You know what my favorite language is, right?
The one you get paid for working in.
The one that they pay me to write in. Absolutely. Yes. I mean, there are philosophically, theoretically, all types of languages that I prefer over one another. But really practically for me, I write software to make a living, right? So I want to use something that is going to help me do that, right? So if I'm more likely to get a job writing Python, I'm going to go for it, right? Whatever, right? It just depends on what your goals are when you pick what language to focus on. But if you are just getting started, like Steve said, it's not a bad path to choose to pick a scripting language and
a dynamically typed language.
Yeah,
typically a scripting language.
Right.
JavaScript scripted, right?
Yes. Yeah. And then also like a more object-oriented, strongly typed language like a C# or a Java, something like that. I see a lot of PHP coming in. We haven't even talked about PHP. Again, if you want us to cover, I see Erlang. I guess people are putting in the comments now what languages they want to see. So yeah, we'll definitely pepper in different languages as we go.
There's an interesting comment from Joey. Just popped in. Does JavaScript have a place with AWS? Yes, it does, because you can write Lambda functions in JavaScript or Node, right? You can call AWS services from JavaScript, right? We have an SDK for it.
Yeah,
right? We have an SDK for most languages, right? So yes, it does have a place. It's not just for writing scripts on a web page. So
I'm getting nervous because we're getting a lot of Rust, and Rust is
maybe we need to learn Rust. I don't know.
It's a little challenging for sure, but look, I'm up for the challenge. If we want to do some Rust, we can do some Rust for sure.
All right. Shall we look at some code?
Yeah, let's get into code for sure. So beginner's corner, I'm going to put that up again. Too.
All right.
Just so that, because we went off on a tangent there. Some of the questions in chat answered though. Again, keep those coming.
Yeah,
like, please interrupt us. You know, we're not on any type of deadline here. We want to talk with you all.
Yeah. All right. So last time out, we were looking at Python, and you were using a REPL, right? You using Python at the command line, right? And I think I made a comment about, I've never seen one for C#. I've seen one in Visual Studio, which is the most popular IDE for .NET development.
Right.
But I've never seen one out in the wild. Well, it turns out there is such a thing.
Oh, wow. Hey, Steve, can you make your terminal a little bit bigger?
Yes, I can do that. Open up my profiles here. C#. I thought I'd already made it larger, but maybe I closed it by accident. It happens.
It does. It definitely does.
Is that better? 24? Will that work for you?
Maybe one more. Sorry, you already. Okay. I think you can do Command plus on the terminal.
Can I? Yeah. Sometimes if you do that though, it doesn't wrap very well when it
starts
doing stuff. So let's do it properly. Let's go for 25. How about that?
Okay, sounds good.
You good with that?
Doesn't cost you anything to go to 25.
No, it doesn't cost me anything. It's a freebie. All right, there we go. All my consoles should be up at 25 now. All right. So, but what I found was there are in fact REPLs out there for C#. Now, if you're not familiar with a REPL,
what's a REPL, Steve?
Read, evaluate, print, loop type environment. So you can type in commands and then have them evaluated, the result printed out, and then you continue. That's the looping part, right? So turns out what I found was, going back to this, is this thing here. Now, this is not a recommendation for this by any means. This is the first one I found. There were a couple. This is called C# REPL. It's on GitHub. So it's a cross-platform one, which, ideal because I know working on a Mac, now that we have .NET cross-platform.
Right.
But you can type in commands. So this is the one I'm going to use today in the console. So let's just jump in here. And one of the first thing I want to do is, when we were working with Python last week, you created a variable, right? And I can't remember how the variable was set up. But the first immediate difference is, well, when you look at the two languages, right? We have numbers, we have strings, right? Numbers are ints, longs, floats. We have strings, we have types like booleans, and other different types, right? The difference with C# and most static compile languages is you have to declare the type when you declare the variable.
Right.
Whereas you were just able to just assign the variable. Right. So in C#, in fact, if I start the REPL right now, okay, so now I'm inside a C# REPL. Okay?
Nice.
I can't just say that won't work. I don't want that equals 1. Right? Because it doesn't know what A is at this point. I have to tell it, right? So I can say int A equals 1. I'm going to put semicolons in here because it's muscle memory. Right? Trying to print it out, right? So A is 1. So I have a number.
Okay.
Right now, right? Now, the first thing you did when we were doing the Python one was you went, oh, okay, let's go A equals test. Now in Python, that works because Python has a dynamic type system, right?
That's right.
In C#, that's going to error out. You cannot implicitly convert the string to an int.
Right.
Right. I can cast it. Right. I can actually have the compiler do some work for me. Not this particular way around, because test won't evaluate as a number. But if it was the other way around, if it was a string and I wanted to put a number into it, so let me actually create a string, right? String, let's go B equals hello.
Yeah, this actually comes up a bunch when you're taking input, for example, from the command line, and that input is always going to come in as a string.
Just as a string, right?
But let's say you're trying to get a number, like how many times would you like me to iterate through this thing? The input from the user is going to come in as a string, no matter what you do.
Right. So I can't do that, right?
Oh yeah, because B is now a string, right? Or B was always a string.
Let's try this. See if it'll convert this. Sometimes it will. Can't convert like that, right? So what I'd have to do is parse it. So I'd have to do int.parse. Should go to a string. Oh no, can't do that. Convert it into a string. Getting the wrong way around. All right.
You could do string to int. Yeah, you could do like a string literal, like quotes 10 in quote.
Yes, I could do that. Yes, and then do that. Yes. So yeah, I can do this.
Let's try that.
10. What was A? A was B was a number, right?
B is a string. You have to use
I'm not very good at naming my variables.
You gotta use A. A is your int variable.
A is my int variable, right?
Yeah.
To string. So I can do this.
Well, 10 in quotes is already a string. Yeah.
B is already a quote. Was it? I thought A was my number.
No. So now do A is equal to int.parse. And then put B. Now do A. Hey, it's 10. There you go.
So that's how you'd have to do it in a strongly typed language, right? And if you're doing this in TypeScript would also flag the fact you're trying to put a string into a number, right?
What about this, Steve?
Is there type inference? Type inference.
There is, like
yes,
with
there is.
const,
Indeed,
right?
there is. So var.
Yeah.
In C# you use a keyword called var, right? So actually, I'm going to say a number this time around. Now I can do get type on this. Can I do get type on this? Yeah, get type. Should report that I didn't have jeopardy the thing. A number. Well, a number is a number now anyway.
It's a number.
Right. Yes. So if you know the so let me backtrack. So type inference works when the compiler can evaluate what's on the right-hand side of the assignment and predict what the actual value is going to be. Is it a number, a string, etc. Right?
Right.
If the compiler can't evaluate that, then you have to actually explicitly put the type in, right? So what you'll see in a lot of code is things like, I don't have this type defined, but my extremely long, we're going to get into types and classes in a second, right? My extremely long type name, A equals A, stop predicting equals new, my extremely long type name. Or at least I would if I could type, right?
You did this to yourself.
Oh, right.
You did this to yourself.
That's a lot of typing, right?
It is.
If this was a class, and we'll take a look at a class in a minute, that's a lot of typing, right? So a lot of people do, and I do this, is I'll use type inference and say var a, what it happens to be, equals new, my extremely long type name, right? What it's going to be, right? Blah, 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 right? To save myself some typing. It doesn't save me a lot when I've just got an int equals something, right? Saving me a character. So I don't do it there. Now, seems like a complex phrase. It's not really complex. It's just numbers, strings, booleans, and so on. It's just the way I'm presenting it here in the REPL. When we move to an actual class in a minute, you'll see the difference. What was I about to say? Oh, yeah. Now, not everybody likes that approach of using var and type inference, right? Because sometimes what's on the right-hand side, you don't know, right? So if you're working in an editor like, let's say, Vim or VI or things like that, right, where you don't have what we call IntelliSense, where the editor is showing you what the value on the right-hand side, the type of the value on the right-hand side is.
Yes.
When you're reading that code and you're calling a function, or a method is actually called, is a proper name for it, right? Which is returning a value, and you don't know what type that value is, right? When you use var, then you're looking at the code and you have this little cognitive overload, like, well, am I getting a string, a number, a type? What am I getting, right? So in those scenarios, there are people who prefer to actually put the type name in to make it explicit what they're getting from the right-hand side of the assignment. But if you can predict it, or it's clear, like your method's called return me a number, right? Then use var, right? It's a preference thing, right? So yes, that is a long-winded way of defining a variable, right?
Right. Yeah. So again, when you have to declare the type on both sides of the equal signs, right? Like, which you don't in C#, but as Steve's saying, some people don't like that because, it might make it a little less clear on what the variable type is, and you have to read a bit more sometimes.
Yeah. So now I'm in PowerShell.
Okay.
Now, PowerShell is based on .NET, right?
Yeah.
So in PowerShell, variables are given a name by, let's call it var1 equals test, right? Use dollar to introduce the variable. So dollar and var1 is the variable name.
Okay. Test. PowerShell is more like...
PowerShell has a dynamic type system, right? Built on top of C#, right?
Yeah.
So in fact, under the covers, C# also has a dynamic type, right? We were talking about this earlier before the show, right? So you can work with dynamic types in C# and other things, but I don't use that very often. But I figured I'd show you that just because C# is a strongly typed language and it won't let me assign a number to a string or a string to a number variable,
right? I
can do it in PowerShell. Okay.
And let me ask this to you, Steve. I've got an answer as well in case we need to talk through it. But why do I care so deeply about types? Like, what why does it matter that I can declare a type out in my actual code? Does it matter really at the end of the day, or can I switch between types in variables? What do I get by having this system?
You get something called type safety, right? So if you assign, we're going to move on to types in a minute and classes, but let's say that we're using a class, right? Which is like a template for an object, right? And classes have properties, they have methods, they have fields inside them, whatever, right? If I try and assign a value to a variable that's a type, a complex type, right? And then on that variable, I try and access a member, a property or a method, right? If that method or that property doesn't exist in the type that I assigned, I get a runtime error.
That's okay. That's what I was hoping you'd bring up, Steve, is a runtime error.
Now I get an error at runtime. My code blows up because I've attempted to access something that isn't in the type.
Yeah. What does that mean? What is a runtime error? And what is the other types of errors in comparison, right?
Well, there's all sorts of different...
I know there's a bunch, but
right? There's a whole bunch, right? But it's, at the end of the day, the program crashes.
Right. We got a runtime error and a compile time error, typically the two things that you deal with.
Yes,
type,
right? So with type safety languages, you get the error at compile time.
Right. Meaning so before your application
before you even deploy it
to production, let's say.
Correct, right? Whereas with non-type safe languages, you don't see the error until somebody exercises that code at runtime. Now, the error that you get can be a little bit obtuse, right? Yeah. Because you might what might happen in the language is you just get a value null assigned because that property isn't there, right? Now, if your code is able to handle that, like defensive coding, right? I assign a value from a type, from an object to a variable, and then I try and use that value, right? If it's null, right? The best way of handling it is I test first. If this is null, don't access it, right?
Type checking, basically, right? Yeah. Like when you don't know a type ahead of time, you can use type checking.
Right. So you type check it, or you use defensive programming on it, right? You don't just go try and access the member, right?
Right.
It actually is interesting unstructured data coming in here with JSON as well, right? Sometimes you will serialize or deserialize JSON to an object, right, to work with it. We do that a lot in C#, right? If that JSON does not have that property value, and you try and access it, it's going to go bang, right? So that's an example of runtime. You need to be defensive in that code. But that's what it gives you, is that benefit of catching the errors upstream before you actually deploy the code.
Right.
Right.
Sure.
As opposed to trying to catch them at runtime. Now that doesn't always work even in type languages. I just said, right, you can get a data structure back from something that doesn't contain the value you expect, right? So you still have to code somewhat defensively, but basic errors like trying to assign a string to a number variable or the other way around, that kind of thing, it'll catch at compile time. So it's saving you time ultimately.
Yeah. With
what would you rather do? Would you rather catch that error when you're compiling the code, or would you rather catch that error when your pager goes off in the middle of the night because you've deployed it and you didn't have a check?
Right.
And that would I'd rather do.
This does not help for when you encounter things like parsing errors, right? So when you're sending JSON around to various different services,
right?
When the service receives that JSON, if it's improperly formatted, it doesn't matter what language you're using, right? You're going to likely have a parsing error because I would say the parsing error would probably happen more quickly in a language like .NET or C# because you're coercing the JSON that you parse into a class, right? And so that's when it would happen. Whereas in a more dynamically typed language, when you try and access a property that isn't on the object that you get back, that's typically when you'd see, dynamic languages are much more forgiving with improperly formatted JSON than something like C# if you are coercing into a real class in C# instead of using a dynamic object like Steve mentioned earlier.
Yeah. So what we've been doing up till now is not typically how you would work with C#, right?
No.
C# is an object-oriented language, right? It revolves around things like classes, structs, records, actual types that contain not just values, but also what we call behavior or methods or functions, right?
Right.
So I figured what we would do is now let's move on and actually let's write a class hierarchy for something, right?
Okay.
And show how that's done in C#. And then maybe the elegance of the language will start to present itself, because you don't typically start a C# REPL and start banging out variables, right?
Right.
So
classes, Steve. I love that classes allow you, the way that I understood it when I first learned about them, they allow you to organize data and behaviors. And usually the behaviors are related to the data that it is also storing in the class. It's one of the easiest ways that I found to.
Where is writer?
Oh, you going for writer?
Yeah. Oh, there we go. Yeah, I want to open that one. Yes, open that one. Yeah, I figured we'd do something different.
I love it. That's great. Yeah, seeing another IDE. We used Visual Studio Code in last time's episode. So now we got a different IDE. And IDE very quickly is just an environment where you do a lot of development work. It includes a lot of tools that you need to compile code, to run code, to work with code.
Build it, run it, debug it. Or you can use an editor, or you can just do everything from the command line. It's your choice, right?
Yeah.
But this is a typical
your hello world
type of class, right? So what we have is something called a namespace, right? So this is a grouping mechanism, if you like, for the different types in a program, right? You can have multiple namespaces in a program, in a piece of code, right? So for example, if you're writing a web application and you're using MVC, model view controller architectures, right?
Yes.
Which we'll come to, I guess, in a future episode, right? Well, I might have one namespace for my model classes, one for my view classes, one for my controller classes, right? Then I have a class, right? So a class you can think of as, the way I like to think about it when I'm explaining is, it's like a cookie cutter, right? In that I'm defining in the class all the different properties, like the variables, the values that class can hold, as well as the functions or methods that I can run inside that class, right, on that data, right?
Right.
And then when I stamp that cookie cutter into some dough and I get a cookie, that's an object.
Yeah.
Right. So the class is the type and the cookie dough is the object, right?
Can I take a stab at description too?
Yeah, absolutely.
So for me, I one of the more hands-on or practical implementations of classes that really stuck for me was think about cards, right? There are all types of different cards out there in the world. There's playing cards, there's tarot cards, there's Magic the Gathering cards, Steve. Talking about those before we went live as well. All of those cards share the same characteristics, right? Like all of them have similar characteristics that, they might have a number
Right.
assigned to them, or a value, or a rank, or something like that. And so what you do is you define that. We haven't even talked about inheritance yet, but I'm getting
We're
kind of
going to get
ahead
there
of
in a minute.
myself. Yeah. You design a class that can encompass all of the other types of these cards that, and you do that by defining things like, well, they have a rank or a suit, but not everything has a suit. So you try and think back and, disassemble what you're trying to achieve into the most generic set of properties and behaviors as you can when you're designing a class. And then you use that class to make, different types, right? Different types of these things that all share this characteristic.
Different instances.
Yeah.
When you start using the word type.
Thank you.
Yeah.
We didn't even there's things called interfaces in C# that also can, work within this kind of paradigm. There's abstract classes versus concrete class. It gets a little bit more complex.
Yes.
But we'll start simple, right, Steve?
Actually, while we're at that, if you are looking to learn C#,
oh yeah,
let me bring this up. So this is a really good guide. It's the C# programming guide. It's on learn.microsoft.com, and there's a whole bunch of tutorials and background information on C#, etc., that you can find inside there, including the type system, how it works, when you can use var, so type inference versus actually explicitly having to say the variable name, anonymous types where the compiler literally synthesizes a type name for you.
Yeah.
Right, which can be useful if you just program data, structs. Actually, we're coming to structs in a minute. Thank you, Devin. Records and so on. So there's a whole bunch of, and this is one of the reasons I like C#, because C# is a language that it began as a very elegant language, but it's getting better over time. They're adding more and more stuff that just saves you so much effort,
right?
In terms of how things get done. So records, for example, right? Again, this is going to be more advanced for beginners corner than we want to get into right now. But if I'm writing a web application, and that web application is querying a backend database, right? So I'm running let's say a SQL query against a database engine, right?
Yes.
And I get back a .NET object, right? That .NET object that's come back from the query may well have more data in it that I want to send to the web front end. Right. So what we tend to do is we write what's called data transfer objects, DTOs, right? And a DTO is like a cut down version of the data that came back from the back end system. So it might not have like the object key, for example, right? The item key or some other data that's in there, right? So we compress that data down into a DTO, and then we send the DTO back to the front end, and the front end renders it, right? Well, C# invented something called records. And with records, with the DTO, traditionally what I have to do is I'd have to go and define a class for that DTO. Right, and put in the properties that I want it to return, and then when the query comes back, I can use a tool like a mapper to actually map from the data that came back from the database into the DTO and then send that back, right?
Yeah.
Or I can define something called a record, which is new, where I just actually give it a record and I give it the property names, and then the compiler figures out the mapping.
Nice.
And sends it back. I don't have to define it a full-on class. So it's kind of quite elegant. But anyway, if you want to learn C#, I recommend go and hit this. There's a bunch of tutorials, etc. So let's go back to Rider, and we were going to build something. So a class hierarchy. What should we put together?
Can we pause real quick and just do a quick if you're just joining us?
Yes, please do.
If you're just joining us, this is AMster and the Brit's Code Corner. We are discussing C# today. Today is C# day. I said it was Rex Manning day, and I lied because it's C# day instead. But we cover beginning fundamentals to coding in various languages, and then we also at the second half of the episode have a project for people who are further along in their coding journey. But we're here live with you all taking questions. Look at it, chat. So if you've got questions about coding, if you've got questions about C#, today's your day. Let's talk C#. Devin does have a question about what you were just talking about, Steve.
Dictionary record. So a dictionary is a key value structure, right? So the dictionary type has elements inside it that are addressed by keys. The record is a more formal type where the data inside it is accessed by property names. It's kind of similar, but not. A dictionary can hold more than one item. A record holds one thing. A dictionary can hold multiple things addressed by keys. So a DTO is just a compiled version of data. Does it pre-render that data from the back end? No, the rendering happens on the front end. Depending on if you're using JavaScript, you get the DTO back, you render it there. If you're using C#, then the rendering would come from the ASP.NET pipeline, sending HTML back. So, all right. So what we're gonna build as a class hierarchy to illustrate classes and structs and things. What would you like to build?
I mean, we could build a card.
A deck
class,
of cards,
like I was saying. I was using tarot cards as my example, but
what cards?
Tarot, TAROT.
Oh, tarot.
Yeah,
I've heard of them. I'm not entirely sure what they are. Are they?
They predict your future, Steve. Tarot card. No, let's just do playing cards. Yeah, but they have they've got properties, they've got behaviors, right?
Right.
And so we can model that in a class.
Okay, well, let's do that. So let's say we make a card type, right?
Yeah.
Okay, so what properties are you going to want inside here? So
a suit, right?
Okay, so we're going to call it, should we make it a string?
Probably a string, because we've got, clubs, hearts, etc.
So what I'm doing now is I'm introducing what's called a property, right? So this syntax in C# means there's a property on the card object called suit. And the get means that I can read it, right? I thought so. It's not superstition.
Look.
And the set means I can set it. Now, you might be asking, what's this public thing here, right? So if I didn't actually take this out, actually, let me new this thing up, right? So var card, you should have done this in REPL, I don't know, equals var c new card, right? I've created an object and I've put it in a variable called C, right? And you've noticed I've used type inference, right? I didn't say card C equals new card, right? Here I can access the property called suit, right? Because it's got public access.
Right.
If I was to take that away, and let's just say I make this private by default, which is if I don't specify any access modifier, right? This is where IntelliSense is really handy, right? You'll notice that suit is no longer available to me, right? And this is another advantage of strongly typed languages, right? That you can have these access modifiers. If this was JavaScript, I could access a suit property on that object, no problem, even though I didn't want you to access it, right? Is that making sense?
Makes sense to me.
All right. So the other thing that we can do is we can say, let's make this public.
Okay, so now we'll be able to get...
I can access it, but I can remove the setter, right?
Oh.
So now I can only read the data.
Okay.
Right?
Interesting.
The other thing we can do is, let's say, actually, public enum. Actually, what we would probably do with this is call a suit enum.
Yeah, so now we can define out...
Hearts, diamonds. I don't play cards, so you have to help me out here. Suits, diamonds, spades. What sabdies in this particular case? Spades. What else would we use? Hearts, diamonds, spades, clubs. Thank you. I told you I don't play cards. There's a reason board games are called board games.
Swords, pentacles. No, that's not how you said that.
Let's call this card suit, right?
Just kidding.
And here we'll make this the enum card suit. That's it. Okay.
Yeah, chat did not like my tarot suggestion, so I'm glad we went with playing cards instead.
Oh dear. All right. Now the other thing that we can do with this is you'll notice that I can read the card suit, but I can't set it from anywhere, right? So back in this code here, I can't say c.cardsuit, c.suit rather. You need a public get, right, equals cardsuit.clubs, right? You'll notice that that's erroring out. There's no setter. So I can't just blindly add this in, right? If I put on set here, now I have a setter. Now it's available, right? This is Yeah, what this is doing is you ignore that green squiggle. It's a nice handy thing in C# where you can initialize an object inside the new statement.
I love this. I love this. I
Are
want this
you
frame.
getting tied up in your tarot cards?
No. I'm a complex thinker. I want this comment framed. I love it.
I'm going to take the setter away. All right.
So now we can't set the suit. We can only
can't set it directly outside. Once the card's been created, tough, right? We can only read it, right? The other thing is, what's the name given to the number of like 3 of hearts or 7 of spades?
Oh, yeah. I think that's called something like value, maybe.
Value? Don't want to use value.
Well, but maybe it's rank, actually.
Rank. Oh, okay. Rank.
Because you can also have aces, queens, kings. So those are different than the suits.
That's true. So
you have 1 through 10, right?
Yeah, and then you have king, jack, queen, right? So how would we model that as a value? You could use a value, right? You could mark 11 as a jack, 12 as a queen, 13 as a king.
Yeah.
Ace is 1. Well,
1 or
not always
11.
1, right?
Wait, that's blackjack. No. Actually, it is. It would be 1 in most cases because we start numbering at 2 on the cards. There's not a 1 card in a deck of cards. We know less about cards than we do about
C#. Right? Maybe we should have used musical instruments.
Yeah.
But this is an interest. But the thing is, this is an interesting exercise when you're learning a language.
Right.
Right. It doesn't matter what language it is, whether it's dynamically. Oh yeah, that's true. You have jokers too. Thank you, Umar.
I thought he was talking about. I thought he was saying about me.
But it's an interesting thing to do, right? So you're learning a new language. It doesn't matter whether you're an experienced coder or whether you're brand new to coding, right? Is to pick something real world, like furniture or pets or musical instruments. Doesn't matter what it is, right? But something that has a kind of a hierarchy to it and different types of those things, right? So you have chairs, tables, etc. No, continue with the cards. I'm going to try. Right.
Look at this from Isaiah too. This is why we do it, Isaiah. That's why we cover so many languages. Glad to hear that it's helpful to you.
Yeah. Right. So pick something and then try and model it in the language that you're learning. Right. That's kind of a little bit more useful, in my opinion, than just doing exercises where you're saying, okay, let's compute the value of pi to, I don't know, the nth value using this language, right? Who cares, frankly, right? Pick something and go model it, right? And I'll give you a good example. I did an interview once. I was on the receiving end of the interview and I passed because I'm here, where I had to actually model the game of Monopoly.
Oh, wow. Okay.
Right. In classes, right? In a 1-hour interview.
I guess you got properties. You've got
properties, right? You got the properties on the board, right? You've got whether they have houses on them right now or hotels. What's the rent? So on. So there's method inside. There's behavior inside those properties, right? If a player lands on it, you have to calculate the rent, right? You know the base rent. You know the number of houses and hotels. Right. So there's a whole bunch of things inside there that is actually a lot of fun to do.
Right.
Okay.
There you go.
All right. So where did we end up with the rank? So you thought there a number would be enough?
Yeah, because we could just if it's equal to 1. Because look, like let's think about it this way, right? To the backend system, it doesn't really matter how we display. Right. We just need to know that 1 equates to ace or 11 equates to jack. Right.
Right. Yeah.
So we just need some kind of dictionary, I'd say, to figure that out later. But interesting.
Ace.
Okay. Okay.
Right. Return.
So this is actually now we're moving into methods.
Right. You'll notice that Ryder's telling me that this method, this property could be made private. That's because it doesn't know that I'm not using it outside anywhere.
Right.
So ignore the green squiggles, right? And we could do the same thing for, I'm not going to write all these out, but bool is the true false type in C#, right?
Right.
Is a king. I'm not saying I would necessarily write this like this all the way, but
right.
And
just to be clear to chat, this is not, these are playing cards. These
are
we're
just messing around here, right?
Used in like blackjack and poker and things like that.
Right.
Yeah.
Right. So we've got that. So the public means that I can access it, right? I can call this from outside. So without that, if I newed up this card, without that, I wouldn't be able to access that method, right?
Right. Yeah, because so there are ways to access methods on classes without having an instance of the class.
Right.
But these are instance methods.
These are instance methods, right? Now I could also make, let me think, what would be a static method with a card? A static method here is shared by all instances of the class, right? Card.
Well, you don't even need an instance. No, you can call it from the class itself. What if you you wanted a static? Oh, deal. Okay, interesting. I was going to say a good static method might just be show possible, like show a full deck, you know.
Rank equals, I don't know, rank equals, let's say 5, and suit equals, why won't you let me access that thing? Card suit equals card suit diamonds, right? Return the 5 of diamonds. All right, what does it like here in the side here? Public static property cannot be assigned to. Well, that's true, right? Because I didn't give it a setter, right? Again, type safety to the rescue, right?
Right.
If this was a dynamic language and I just deployed this, that code would blow up at runtime, right? Which is why I like this. So let's give it a private setter. There we go.
All right, so
now we're in private accessibility, right?
So anybody can read from the class,
right? But only the class itself can.
The class itself can set,
right?
Okay,
yeah. Right, so that's what private means.
There's and this also, is for inheritance, right? Like which we haven't talked about. Well, primarily, it's for inheritance.
Yes and no, right? So with inheritance, we typically use an access modifier called protected.
Right.
And what protected means is the class itself, the instance itself, or its derived classes, derived types from that class can access that member, be it a property, be it a method, be it a field, right? So everything I've done so far in here, I've added actual properties, right? I can also do things inside here like create fields. So I can say public. You typically wouldn't do this. You can say public int, I don't know, some value, right?
Right.
That I can access and write things to. Typically, you access C# object properties through a property declaration. You don't just write random fields in there. But
you can also set public, private, and protected methods as well.
You can have public, private, protected methods. Yeah. Right. So here now, for example, I can say var C equals, instead of saying new card, I can say card.deal. Right? So that deal method there, that static method, that's like a factory method. What we call a factory method, right? It creates an object for me, right?
Yes.
And it returns a pre-initialized object of some form, right? So I have that. The other thing you can do with classes in C# is you can do, actually, one other thing I want to do, I'm not going to use this value, but you can do things like const.
We got a question from Devin. Protected.
Does it work for, it works for children of children. Yes, it goes all the way down the chain. So classes that are higher in the chain can't see that protected member, but the classes below it can. The types below can, right? Public const inst, and again, I'm just going to do constant equals 10, right? So in C#, and like Java and like most strong languages, you have the concept of variables, of values that you can read and write, subject to access modifiers that we've been using, right? You can also have constants, right?
Yes.
So let me go back to the REPL for a moment, and C# REPL.
These are values that can't change.
Const int a equals 10. right? That's an integer. It's a number, right?
It is.
What I can't do is that.
You can't change that value.
I cannot change that constant, right?
Right.
Now, C# also has the concept of read-only. Now, you might be asking yourself, what's the difference between constant and read-only, right?
I am asking myself that. Yeah.
I'm glad that you asked. Right. So in C#, when you have a constant, let's say I'm writing some code, right?
Yeah.
And I'm referencing a type that has a constant value inside it, right? When I compile the code, the output binary will actually take that value and put it into my code, right?
Okay.
So on my left hand here is my code,
right,
that I'm running. On my right hand here is some library that I'm accessing, right? Here's my right hand, right? Let's say that has a constant in it called 5, of a value of 5, right? That value of 5 will be lifted up by the compiler and put into my code,
right.
If I change this value now to be 10, this code doesn't change. It still sees 5, even though it's referencing this code over here, right? If I don't recompile, it doesn't see the change. Now, with read-only, what happens is the compiler takes the value. Which hand is it? This hand. I feel
like we're playing like a.
Yeah, this is cool, right? The compiler takes
Which
the
hand?
location of this value and puts that in my code. So when I make a change over here, even if I don't recompile this code, it sees the change.
Okay.
Right.
Interesting.
There's a very subtle difference. This catches people out. It's the same as things like classes and structs. What's the difference between a class and a struct? Right? They both look the same, right?
Stored in memory, right?
The difference is that a class is what we call a reference type.
Yeah.
Right. And what a reference type means is when you assign a variable to a reference type, you effectively get, again, we kind of touched on this the last time with Python, right? It's not the memory address of the object, but it's a reference to the object, right?
Right.
So two variables looking at the same type, reference type, if the reference type changes, they both see the change.
Right.
If a value type, which is a struct, is actually copied by value. So let me show you this inside here. So
yeah, this is something that can get really confusing.
This gets really confusing, but this catches people out, right? This is something you need to know, right?
Yeah.
So let me create something here called a struct. So let's define a struct. Let's call it my struct, right? And I'm going to do everything in one line. And we're going to say public a number. Oops, I need the type, obviously, because I'm in a structured type language. A number, public string, a string. I'm not very creative in my variable names, I know, right?
I'm not saying anything.
So var struct1 equals new my struct, right?
Yeah, we had a question from chat too.
Yep.
Do they both refer to the same address
memory? I'm going to show you right now, Umar, right?
That's what I thought.
So what I'm going to do is I'm going to give struct1's number a value of, let's say, 5, okay? And s1's a string equals hello. Okay?
There you go.
Good so far. Let's see if I can echo this out. No, it doesn't do it that way. It gives me a type. Okay, right. Let's do var s2 equals s1. But is S2 S1?
I'm going to frame this comment for you.
Awesome.
Look,
well, let me expand on that as well as to why you would use a class versus a struct, right?
Before you do, I want to give your credentials. I have special credentials that I don't even think you maybe know about, why you are the greatest person to be teaching C#.
I very much doubt that statement, but okay.
I believe you are, because I went the other day and I saw on Twitter, you were the only person on Twitter that I know that follows the Wix Twitter account.
Oh,
which Wix is the Windows installer software, right? And I don't know anyone else who follows that Twitter account. So you, sir, to me, you're the most qualified. Anyway,
I would dispute that, but okay. All right. So we've assigned S2 a new variable, right, to S1, struct2 to struct1, right? If I do S2 a number, I see 5, right? That's what I initialized it with, right? What's the value of S2 a number done? A number right now. I've just changed the value in S1.
Yeah.
To be 20.
Right.
Answers in the comments.
Yeah. What do you all think? What's the what is s2.number
I have
set?
two structs, right? I defined a struct, right? In struct 1, I put the number 5.
Right.
In struct 2, the reference to struct 2, I put the value 20.
It's still 5 because it's by value.
5 because structs are value types, so they're copied,
value.
right? They're copied. Now, if we do the same thing with classes, you'll see the difference. So class, what do I call it? My class.
Joey,
again, I'll just do this in line, right? A number. Oh, I need an int, obviously. You'd think I've been working in dynamic languages recently, wouldn't you?
This feels like one of those interview questions that you'd get.
Sometimes you do get this, right? Okay, so var c1 equals new my class. Right? I have a class. I have a reference type now. Okay? C1 dot. Again, we'll do the same thing. Is 5. All right. Var c2 equals c1. So now I have 2 class references.
Right.
Okay. C2 dot a number. Print that out. It's 5. Cool. Let's change C1's number to 20. All right. C2 sees 20 now.
Yeah, because that's because
it's a reference type, right? So C1 and C2 are both looking at the same object instance, whereas struct 1 and struct 2 are looking at 2 different copies because they're value types. Okay. If a struct is a value type, can you use byref for a method parameter? Oh, that's a good question. I've never tried that. I'm going to make a note of that to try it later on.
Byref meaning pass by reference, which is how you can pass in a parameter to a method, either the value of what you're trying to pass into the method or the memory address, right?
So basically, am I passing a copy or am I passing a reference to the original copy?
And all of this goes down to basically how these things are stored in memory, right? Like it could either be... So when you were talking about const earlier too, I had a question. Does C# const only support primitive types because it's uplifting it in code, or can you have a const as a defined class, right?
As a type like string? Well, string is a class.
Well, no, that's a Oh, yeah, I guess you're right.
It's also a primitive.
But something like you know, our card. Could you set const? C equal to new card.
I'm trying to think if there's a case where I might have done that.
I don't know.
Answer yes or no. I don't actually know. Again, I'd have to go and play with that.
Yeah, but all of it points to how things are stored in memory, which can be really confusing for a beginner of how variables, classes, all these things get passed around in memory. I'm
trying to think. I've got a feeling like with const, because I remember from my C and C++ days that depending on where you put the const, the reference was const or the object was const. Right. And I don't know if that got inherited into C#. I'd have to go and play with that. I don't know.
But Devin says anything.
I'm going to go find out.
Yeah. And then in C, right?
Yeah.
Not C#, obviously. C and C++ for that matter. You've got these things called pointers, right? Golang uses pointers as well. It's a little different than the pointers in C and C++. But we're not using pointers necessarily. Pass by reference and pointer are not identical, right? We can't call them the same thing, but they are similar, right? There are definitely things.
Yeah. Now, Naveen has just put up an interesting comment, use string builder, which brings me to the next point, because we'll need to move on to Project Corner in a bit, but we're going to see some more C# anyway. Strings in C# are immutable. So what this means is that when I do something like string equals, this is why I don't live code. Right?
All right.
That value is now fixed. Right?
Yes.
If I was to do this, I now have 2 strings. Test is now going to be garbage collected at some point in the future, right? It's not referenced, but essentially the assignment of the value world returned a new string.
You introduced the term there, Steve, and since we're still in beginner's corner, I have to call out garbage collected, right?
Oh, yeah. Well, C#.NET is a managed environment, a managed runtime environment, right? So when an object periodically, it runs what's called a garbage collector, and it's looking for values, objects, things that are no longer being referenced, right? And then it frees up that memory,
right?
So, which is how you get around memory leaks.
In other languages that don't have the feature of garbage collection, again, C is a good example of this. You actually have to manage the memory yourself,
right? Yes.
You allocate blocks of memory, and then you are also responsible for deallocating those blocks of memory.
So C# is like Java. Behind the scenes, there's a garbage collector that's watching memory load. It either runs periodically or it runs when memory gets low. It'll analyze all the objects in the code and go, yeah, this thing here is not referenced anymore. We can bin it and free that up for something else, right?
There you go. Look at
printing a memory address. Perfect. Thank you. Yeah. So the reference to string builder was basically, if you're doing string concatenation in C#, then don't do this. So var a equals I'm going to call these string1 plus string2. Pretend these are just variables I've declared plus string3, right? Because what happens is that as the compiler's running through this runtime, it's allocating multiple strings.
Right.
Each one is creating a new immutable string, right? What you would do is you'd create a string builder, right? And a string builder object has methods on it that let you append strings.
Right.
And then when you're finished with it, when you finish building the string, you just say, you call a method called toString on it, which sounds a bit weird, but toString, and then that returns the immutable string into your variable.
Is this
one way of doing it? That's how we used to do it, right?
Is this a instance of what people refer to as lazy loading? Or not quite?
No. Okay. Lazy loading typically in C# means that you've got some code in a library somewhere that you dynamically load when you need it. Not
okay.
But
yeah, it doesn't read stuff into memory until you actually need it. Right. That's why I thought maybe the strings were being handled that way as well.
The new way in C# of doing that, right, is to use what's called string interpolation.
Oh yeah.
Right. So
a template string
equals, and you use $1 and a quote to introduce that, right? So this is and then we can use something like C1.a number.
Right.
Type out S now. See how the value 20 has gone in there, right?
Yes.
That's typically how you build strings now at runtime in C#. You can use the string builder approach, which works still fine. It's, in fact, for some cases that might be easier, or you can do string interpolation. So string builder just like a list char-like structure. Yes, that's how I tend to think of it. Yes. And it has methods on for like removing bits, removing substrings, inserting substrings, appending strings, and so on. But it's managing the underlying structure of all the characters.
Right.
And then when you finish building it, you call a toString method and it returns the string value, which is then immutable.
But it's not doing memory optimization or anything like that.
No, it's not doing any memory optimization. Well, I've actually looked at the code. You know what? .NET now being open source, you could actually go and look at the implementation of String Builder and see exactly what it's doing under the covers.
That's true. Well, Steve, I got to give us a time check here too, because I know we got a project corner, right?
Yes.
This has been a really great beginner's corner, though.
So I think for the next episode, what we should actually do is perhaps in Python or C# or TypeScript even.
Yeah, we could do.
We should build an object model. We should pick something.
Okay.
And we should define a model.
Okay.
Right. And then we could show how it's done in the different what it looks like in the two different languages.
Right. Should we keep it with the cards? You think playing cards?
I don't know. What do you think? SIL classes. So SIL class is one that you cannot derive from.
You're getting some good C# questions.
Yeah, they're good, aren't they? Yeah. So so if I say let's say public sealed, right? Then in C# I can't do something like public.
Can't inherit from it.
Can't inherit from it. Public class, other class. Can't do this. Right? That would be illegal. Okay. Does that make sense? So that's how I can design a class that I don't want anybody to define a class hierarchy from.
Right.
For a particular reason, right? There is another one that you can do. I'm going to mention it briefly before we move on, because you threw it out there earlier on. So right now inside my code, you see how I did this. I'm just switch this out for a moment. New card, right? That creates a new card object, right?
Right. So instantiates a card object. Oh, abstract.
Now
okay.
that's an error. An abstract class is a class you cannot instantiate. Now the way you use this is, the way I typically have used this is, partial classes are good too. That's getting very advanced. So if I have a class hierarchy, right, but it doesn't make sense to instantiate, say, the root of the hierarchy. So let's imagine that we have, let's say we're modeling pets, right? We have cats, we have dogs.
We need to stop at cats. I'm fine.
We have fish, whatever, right? So cats and dogs are probably both members of, say, a mammal class.
Yes.
A mammal-based class, right?
Right. Fish
would be, I don't know, a goldfish. Let's say we have a fish-based class, right? But ultimately, they all come up to a root class called pet.
Okay. So everything is a pet.
It doesn't make sense to say new pet.
Mammals are a more specific type of pet.
I was going to call them furry, but
and then dogs are a more specific type of mammals.
Right.
But dog inherits from mammal and from pet.
And from pet, right? But it doesn't make sense to say new pet, right? I want to say a new dog or a new cat or a new fish or a new goldfish, right? Whatever happens to be, right? So in that case, I would mark the root of the class hierarchy as abstract to stop you newing it up, right? And I think Devin's just mentioned here, abstract is a contract for derived classes. That's right? I can actually guarantee that by putting shared functionality into that base class, that abstract class, that all my derived classes inherit it automatically, or I can declare an interface, which we'll come to in a future code, because we're going to get way down the rabbit hole here, right? Where I can define common behaviors across classes that are not necessarily related by inheritance.
Yes. I had to, we got a shout out from Joey too. Extremely rewarding, Steve. You should feel
that's good.
Some pride there.
So
there is more time, and we're going to be talking about more complex project than some of this beginner stuff. Before we move from Beginner's Corner, could you recommend any kind of free learning resources for people just getting started with C#? There you go. Your C# type.
C# getting started. On the learn.microsoft site. If you just search for C#, it'll bring up a whole bunch of references, one of which is this programming guide, Getting Started, Fundamentals. I remember partial classes back from the day when I used to work in the component object model. That's going back.
Before we jump to Project Corner, shall we do if you're just joining us?
Do it just if you're just joining us, yes.
All right. If you're just joining us, I'm AMster. This is the Brit down here. And today is C# Day, not Rex Manning Day, but it is every day is Rex Manning Day. And every day is Halloween too, Steve. But if you're just joining us, that's how I live my life. We are talking all things coding. So today being C# Day, we're learning all about some intricacies of the C# language. We've been covering coding fundamentals in general along the way. Differences between strongly typed languages, dynamic languages, why you'd use one, why you'd use the other, because you are going to use both, by the way, throughout your career. You will use all kinds of different languages. One of my greatest pieces of advice to you all is continually be searching for something new to learn. And oftentimes that's a new language. The reason why we cover multiple languages on Code Corner, one is because you all are watching, you all want to see other languages, but also it gives you a deeper understanding of programming to know the approaches to these fundamentals of coding that other languages take, right? So it really helps to solidify some of your understanding of not just the philosophy, but even some of the implementation details of programming languages by learning different languages. So we're here. We're about to jump into our Project Corner. So not to leave out anyone, we talk coding fundamentals, and then we go implement some of them in a larger project for those who are, further along in their learning journey. It's Project Corner time. Steve, Project Corner.
Project Corner, backmask. All right. So last time out, you wrote a function called backmask, right? This is a Lambda function. It's going to run only when we request it, right? It's not going to run otherwise, so it's not costing us any money, right? But basically, we're going to give it some text.
This is the Python version.
This is the Python version, right? This is what we came up with last time. It's going to take that text. It's going to convert it to audio using Amazon Polly, one of our services, right? And then you write the code to reverse that audio using FFmpeg, right?
Right.
I hope all this is familiar to you, AM, because you wrote it.
Nope.
Right? And then it returns the base 64 version of that reversed audio as a string. Right.
You know who my least favorite programmer in the world is, Steve?
Me?
No, me in the past. That's my most hated developer, because I'll go back and look at code and be like, who wrote this? And then I'll do git blame. I'm like, I wrote this. Why? Why did I do this?
Yeah, well, there was a lot of whys as I converted this to C#, but anyway, we won't go there. But basically, that was the premise, right? We have a piece of text. We convert it to audio using a cloud service, using Lambda to call Amazon Polly, to call Amazon Polly, right? We get we then reverse the audio, we then base 64 encode it, and then return it as a string as the logical output. Yes, we could put a web application around this, but right now we're just down at the fundamentals level, right? So we're just treating it like an API, right? So let's take a look at what this looks like in .NET. So here's the Python version. So we have some variables up here, right? I would call these constants, as we're about to see, right? We have some libraries and namespaces that you're using in the Python. And then we have the Lambda function that's going to be invoked when we hit the API, right? That's going to check the body, extract the text from the body, convert it to audio, and you have a bunch of functions that do all the work later on. All right? Just so everybody's on the same page. Or at least I hope we are. So now let's get back to, here's Rider. Okay, so here we are inside Rider, and we have a C# project, a .NET project. So I've included some package references that I need for a Lambda function, including our SDK for Polly. All right. And I also found, by the way, a NuGet package for FFmpeg. So you know how you had the FFmpeg binaries and you had some Python wrappers as well? I did, yeah. Right? I found a C# NuGet package or a .NET NuGet package that wraps FFmpeg, right? Which made life really easy, right?
There you go.
So that's kind of my project. And inside here is my Lambda function. So at the top, like we just saw, right, I have some using statements that are the namespaces that my code, the namespace of classes that my code is going to call.
We talked about namespaces earlier.
We briefly mentioned namespaces, right, earlier on. There's our own namespace for this function called backmask, right? Yes. And inside there, I have a class called functions, imaginatively named, right? But you'll notice that I converted your Python variables to constants inside my code.
Oh, okay.
Because I'm not going to change these.
Right.
So make them const straight away, right?
I love that you kept my default voice, by the way.
Yeah, I kept the default voice.
Really appreciate that you kept Justin.
And then I have a couple of properties inside here for the SDK's client to call Polly. All right. And I'm going to extract the logger, which I get handed to, my function receives from Lambda when it runs. I get an instance of a logger, right? That I'm going to write some logs out. Inside here, I have what we call a constructor. We didn't talk about constructors today, but typically classes can have constructors, right? Yes. That initialize the object before it's returned, right?
Right. So you might need to do some setup, right?
There's doing some setup, right? So inside here, what I'm doing is I'm registering some global options for FFmpeg to say where the temporary output folder is going to be when this code runs. And I'm instantiating a new SDK client from our SDK for .NET to call Amazon Polly.
Okay.
And I'm just assigning that into this property up here, which you'll notice is just a getter.
Right.
Because I'm initializing it in the constructor.
Are you going to talk at all? Some of these packages, obviously, are not packages that you wrote or libraries that you wrote. You're pulling them in. You're going to talk at all about NuGet?
We will do later on.
Okay, great.
Yeah. You'll notice that the logger, though, is get and set. Right? I could have made this private set. I was just, actually, it is by default private set, right? And the reason for that is I'm not initializing it in the constructor. I don't have it at this point in time. I only get it when the function runs.
Right.
So that's when I initialize the logger.
Okay.
Right? So this object here, the context, I take the logger out and I put it in this property because my methods later on are going to use it, right?
Right.
Then I've got pretty much the same code that you've got, right? I do some defensive text to make sure, did you actually give me some content to change, to make audio, right? Unlike you, I get a voice, I allow a voice to be passed in on the request.
No, you don't need to change the voice.
You like Justin, I like the
voice is perfect.
Okay. I then extract the text from the body. I check that it doesn't exceed the maximum length that we set, right? We set a limit of 3,000 characters because we don't want to be silly, right? And then I'm returning some error codes if you don't pass the validations, right?
Oh, the max characters were due to more of a practical reason.
Well, yeah.
Right, because we can't exceed that amount of characters when sending over to Poly unless we send to Poly asynchronously.
We're doing async, right? Yeah, we're doing it synchronously. So
we can't, when responding via this is fronted by an API gateway, which expects a response in, I think, less than 30 seconds. But really, it should be immediate anyway. So like we could recode or refactor this to use the asynchronous call to Poly, but it would take some more infrastructure changes too.
Yeah. So I'm logging out some information on what I'm doing, and you'll notice I'm using string interpolation that I just showed you, right? To inject the voice and the text I'm going to change. Then I call a method on this class to convert it to audio.
Okay.
Right, and get back encoded audio, which I then return as the body. All right, and then down here is the code to actually call Poly using our SDK. This is the actual work that does the backmask, right? So I call Poly to say, please encode this as audio.
Okay.
When I've got that, I reverse it, and then I return a base 64 version of it, right? And here's the code to generate the audio files. This is calling Amazon Poly using our SDK, right? I new up a request object that says, here's the text to convert. I want MP3 as the format and use this voice. All right.
Now, Steve, I don't want you to have to go too deep into this, but this might be a little confusing because we just talked about synchronous and asynchronous in terms of Poly. And then you see synthesized speech async. That doesn't mean how Poly returns a response.
This is .NET's await async await pattern, right? So what will happen is the call will go out to the service, which will do a synchronous job. While it's working, the code here can get on with other stuff if need be, but it's going to wait that response to come back before it actually logically proceeds, right?
This is how you handle.
Very deep.
Yeah, you handle things like input output with asynchronous calls. You handle things like network, like I'm sending something over the network, which is what you were doing in the case of synthesized speech.
Yeah. So once I get that audio back, once the service comes back, I take the response and I put it into a file on the Lambda temporary file. And here's my code to reverse audio.
There's another async. Call,
You'll find that around. All IO operations in .NET, in cross-platform .NET, are async by default.
That's input-output that you're dealing with, not network in that case.
Right. So then I actually use that FFmpeg wrapper to actually reverse the audio. All right. And then once I've done all that, I just base 64 encode it, which is nice because that's built into .NET. All right. So let's deploy that, right? I also, like you, I have a layer that says, hey, here's my FFmpeg binaries that need to be made available to Lambda, right? And then I have a CloudFormation template that actually has the function definition in it to deploy and an API, right? So we covered all of that in the last episode, the infrastructure. So let's go ahead and deploy it, right? So I need to find my terminal, which is here. And let's see, here's backmask. So here's the right folder. Let me clear up all this mess from earlier on. I was messing around with something. Where am I? Right, so I'm sitting in the root. So I'm going to do a SAM build. I'm using the serverless application model CLI, command line tool, right?
You knew where I was going, didn't you, Steve?
Yeah, I knew exactly where you were going. So I'm going to build that. All right, now I'm going to deploy it. And I'm going to deploy it with a particular set of credentials because using default, and I'm going to deploy it to the US West 2 region, right? Because that's where I'm based. and we may as well turn on guided so we get the prompts. All right.
You're based inside the US,
US West 2, yes.
Uh,
So let's give this a name. We'll call it backmask, right? Region, it's preset from my command line. Confirm change before deploy. Sure, why not, right? Yes, it's going to need a role. It needs permissions to call poly, so it has to do that. Table rollback, apparently don't care. Authorization defined, yeah, that's fine because it's an anonymous API for the next 20 minutes. Save arguments to config file, sure, because I'm going to redeploy it. The file and go. Okay, so now what it's doing is it's taking that SAM build output, it's packaging it up as a zip file,
yes.
and it's sending it off to CloudFormation to actually provision the infrastructure, right? Okay. So the Lambda function, the API that's going to front it, and so on. And when it's finished, we'll get back a URL to the API endpoint. Okay, this will take a few moments. There's a question from Umar for you, AM. Are the previous episodes available to rewatch?
I'm looking at our YouTube channel. I don't believe our episode has been uploaded there yet. You can find the old episode, and I'll link to the Twitch version of this. You can find the video on the LinkedIn page. However, I'll just send a link to the actual Twitch one, which is a little easier to navigate to. And then everything is eventually consistent, I would say, consistently uploaded to YouTube. And so we have a YouTube channel with AWS events, but I'll send the Twitch link for everybody for the first episode of Code Corner.
Okay. Nearly there. So this is fully serverless, right? There's no resources are going to be used until I actually call it. Right, there we go, we're done. So here's our API endpoint, right?
Okay.
The function, all right? So I'm going to copy that. And then I have Postman open somewhere. So let's use Postman to actually post a request. I'm going to put the URL. This is going to look really small on screen. I apologize. I don't know how to zoom this particular tool. I'm going to change this to be a post because we said it had to be a post, right? And then we're going to give it a body, and we'll give it some text and say, hello, Amazon Polly. Please be so kind, because you should always be nice to services. So kind.
Yes.
So kind as to convert. Of course, I should do a type. Convert this to audio so I can backmask it. Thank you. And that's nice and polite, right? Fingers crossed. Hit send. And we should get back, if everything's working, we should get back a base 64 encoded chunk of text. There it is. There is the reversed audio base 64 encoded. So let's copy all of that. And my menu is way off screen. Copy it. The benefit of multiple monitors, eh? Right, so over back here, I'm going to back into this window, and I'm going to jump into PowerShell for a little while because we're going to actually handle this text. So the first thing I want to do is I'm going to capture that text in what's called a here string. I don't know if you've ever seen this, but here strings are multi-line strings in PowerShell. So
okay.
There's my variable, $encoded, and inside there is all of that text that I just wedged in there, okay? All right, now the next thing I need to do is decode that audio.
Right.
So I'm going to say, okay, so $decoded, and this is, again, beautiful. This is PowerShell, and I'm calling C#, I'm calling .NET classes directly from the command line. From base 64 string is a static method like I showed you earlier on in that code, right? So I can call it without newing up a class. I'm going to pass in my value of encoded. Okay, so now that's decoded that text. There's the bytes of the audio stream now, right? So now we're going to write that to a file. Oops, I'm going to take off casing because that won't work. Come on. System.io file. So that's the namespace and the type. Right, all bytes. Right, let's just call it reversed. .mp3, and the value I want to output to the file is in the variable called decoded. If for some reason, I don't know why, this puts it at a higher level than where I actually am, so I'm going to move that file in here.
Huh, interesting.
I don't know why, I haven't figured this out yet, but anyway, there we go. So now we have some audio. Now I'm going to put my volume up and we're going to try and play this. Hopefully you'll all hear this. Reverse.mp3. Here we go. Hopefully you heard that. I don't know if you did or not. But it's backmasked, right? Now
we heard it. We heard it, Steve. It's terrifying every time I hear it. I love it so much.
All right. Now
I love it.
There's something else that I wanted to do, and that is, if we take a look at this function code here, right, you'll notice that this is C#, right? You had a Lambda, you had a Python function. Let's take a look at your function.
I did.
Did I close it? I don't know if I closed it or not. Yeah, I'm not seeing it. I might have closed it.
Probably did. You didn't respect. You didn't respect my code to begin.
Didn't respect your code. Yeah, it looks like I did. All right.
You took it and you changed it to this C# thing.
Oh, there it is. Oh. There it is. Okay. So here was your Lambda function handler, right? He just said event context. You didn't care, right?
No, and
type, right?
Well, and say, look, I'm doing some type, not even type checking. It's property checking on the object that's coming in through the Lambda. You could say, if not body.
I'm sorry, I've just seen the #1 on iTunes comment.
Yeah, this backmasker really is
okay. But what you'll see is in my code is I had to declare the types, right? So I've got this, let's call it boilerplate, right? That I'm going to take in a request object, a request object type, right? I have the Lambda context type, and then I have a response type. Well, this is all well and good, but it's some overhead that, frankly, I'd rather not have to deal with. Right?
Yours is a proper type, yeah.
Right. So what I'm going to do is I'm going to switch to use what's called our new Lambda annotations framework, right? And we're going to clean out some of this boilerplate.
Okay.
So what we have on NuGet, where's my browser gone? Let's go into NuGet, nuget.org. Okay, this is where all the .NET packages that you can add to your code are stored, right? Distributed.
We aren't talking about NuGet.
Right? Here's
I
NuGet.
thought we would.
So this is our package manager for .NET, right? And we'll find this package called amazon.lambda.annotations, right? And this is some code that turns this kind of boilerplate into this beautiful simplified function.
Gorgeous.
Right?
Beautiful.
So let's do it.
That looks a lot like, if you're familiar with ASP.NET, it looks a lot like an ASP.NET annotation.
Yes, I mean attribute-based coding is familiar to .NET Dev, so this works out really nicely.
But even the REST API annotation, that was on accident, right? That it looks the same.
Yeah. So I'm going to do a command called .NET add package. So I've got the .NET SDK installed. So I've got the CLI, right, the command line interface, right, and I'm going to add this Amazon. First thing I'm going to do. So let's take this existing Lambda function and convert it and see how easy it is, right?
Right.
We're going to add the package.
And so we saw this last time with pip, right? Which is the Python.
Right. Use the pip one, right? Yeah.
Right.
So I'm going to
this
back
is the same, but for
okay.
.NET.
So let's go back into Rider. Okay. And let's start converting this function. So the first thing I'm going to do is I'm going to add an attribute, which we represent inside C# with square brackets called Lambda function, right? Now this will complain a little bit because it's going to want a namespace, right? So let's do this up here already. So I'm going to add in using Amazon.lambda annotations. Okay.
All right.
We got our Lambda function declared. Now the other thing that I'm going to want is an API, right?
Yes.
It's going to front this function with an API. So we're going to put HTTP API, right? Okay, so now I need another namespace declaration in here. So we're going to take this one and say using. Freaking me out a little bit that Rider is not updating my namespace here. Thankfully, I kept notes. In fact, I even kept an actual branch. We could just switch the branch and not have me code it out live. But
you and me both are over preparers for sure.
All right. So we've done that one. So now we know that the API function that we want is a post method, right? So there's a lambda. Let me get the right one here. Actually, let me build this for a second. Let's see if this trips the IntelliSense. Current does not contain. Oh, because I'm not in that folder. Oh, I know why. It's because I actually came into this from outside of Rider. Let me open.
Yeah, you added that package in too. Maybe it hasn't actually.
Well, no, that's okay.
Is that okay?
But what the difference is because I'm outside of the folder hierarchy.
Okay.
So let me quit from Rider for a minute.
As you know, I'm a VS Code.
Yeah, let's do it
type of guy.
Well, I thought about showing VS Code, but we used that last time.
We did. I love that you brought in Rider. JetBrains makes really great IDEs.
So we'll let that open. Okay. So here we are. This is better. Yeah, don't tell me that. I know about Git. Leave me alone. Okay, so here we go. So now I've got the red squiggles, right? So here are my methods, right? So this is going to be a post method, okay? And what I want is the routing on this. If you remember on the API, it had that backmask.
Yeah.
I might want to put different functions behind different API paths, right? So there's my path, right?
Now, so Steve, when you say you've got the red squiggles, is there a cure for that? What?
Yeah, you fix the compile error. Yeah,
that's right. So yeah, red squiggles in most IDEs means something's wrong in your code.
Yes.
For any of
our
beginners.
So now I'm going to change this. So instead of returning this explicit type, I'm going to use what's called a HTTP result, right? Because I want to return like 400s or 500s if things go wrong, right?
Right.
And then I'm going to change the method signature. So instead of this grungy class that, get rid of this. Get rid of this. Okay, so we know that we're going to take string, right? Which is we're going to call this voice override, right? Because I want to be able to change the voice, right?
I don't know why.
I also
don't understand
string, which we're going to call text to backmask.
Did you get data on this feature request before we implement it?
Did I get what?
Did you get data on this feature request? Are there people asking to change the voice ID? Because I don't believe you that people want to change the voice ID.
Yes, I did.
I don't think we should commit this time to building this feature request.
All right, we have 10 minutes, right? Let's do it.
Okay.
So we know that the voice override in my particular case is going to come from the query parameters. So I'm going to attribute and say, hey, this parameter comes from the query string, right? Yes. The annotations framework will take care of all the work of going to the parameter string, getting that parameter and binding it to that variable, right? The text to backmask is going to come from the body, right? We saw that when I tested it, right?
Correct.
So now this code here goes away, right? So you see how I'm checking the body for text, right?
I do.
So I'm going to replace that with what I've already pre-written because I'm lazy and we don't want to see this, right? So I'm going to do this and I'm going to, hopefully paste all the way down here and change all of this, right? Probably make a mess. There we go. Much simpler code, right? Did I get some text to backmask? If I didn't, throw a bad request.
This hurts my soul.
Take the voice,
Justin,
right?
Justin's going away.
If my backmasking text is longer than I said I will allow, throw an error, right? Nice. I like that. Save me some work. And then the other thing I'm going to do is I'm going to change the response here of the overall function, right? If you remember, we had this grungy bit here where we have to return up a proxy response. Let's get rid of that and just say return HTTP results okay with the encoded audio. Boom. Nice. All right. And for the error one, I'm just going to return HTTP internal server error because something went wrong in my function on my side. It wasn't due to code that you gave me, right? So we'll just say something went wrong. Something went wrong. I think we're going to run over a little bit on our show time today.
That's okay. I don't think anybody's next.
All right. So I have a red squiggle down here that I need to fix. What's my action list here? Oh yeah, void. No, I want HTTP result. That's definitely what I want. Leave me alone. Okay. So let's see if this builds.
I love how you talk to your IDE the same way that
you talk
to me.
My IDEs. Whoops.
But no, you talk to it in the same tone of voice and using the same words as when you talk.
Oh, I know where it is.
To me, Steve.
not all code paths return. Okay, try return. Okay, catch. Oh, I forgot the return. That's why. There we go.
There
we go. All right. Oop, I don't want to paste.
If you
all right, it builds. All right. Well, that's okay. But there's still a little bit of grunge in here. Let me get rid of this window. There's still a bit of grunge in here. You'll notice that I took from the Lambda context this logger.
Yeah, look, there's Eddie Vedder right there.
Well, I don't want that. What I'm going to do is I'm going to use that new Power Tools library I showed you at the start. I'm going to put that in. Right?
Yeah. She's ignoring my foolishness.
I am ignoring your foolishness, yes. So I'm going to add another package. This is that Power Tools package that I showed you earlier on. Lambda dot Power Tools. I think this is the right syntax for it. Logging. Fingers crossed. All right. We now have that package installed. All right. So let's go back to Rider. And what I'm going to do is I'm going to use another attribute. I'm going to say logging.
Oh.
Now we're going to add, once I get this right, let's put this on, import that.
Yeah, you got to pull in the Power Tools, right?
Okay. I'm still going to keep this, the Lambda context, so that's where the logger's coming from. Okay. But I don't need this anymore. I'm going to get rid of this. Whoops. I'm going to get rid of this.
Nice.
And I'm also going to get rid of the storage of that property.
Right. Because the Power Tools instance.
Power Tools will do that for me.
Yeah.
All right. Okay, she builds. That's good. Let's see if it deploys. Moment of truth. All right. So I'm going to CD back to where the template is. Oh, actually, there's one other thing I wanted to show you was I need to make a change to the template. So template.json. So when that code built, what it did, it updated my template. You'll notice, well, you may not have seen this, but the actually application to backmask, let me pull this off into another window over here.
Oh, yeah.
Hang on, no. Let me
template.json.
Yeah, 1 second. Let me open this as a new window. Go away. What it did, it put it into my existing version of code, which is not what I want. So let me get rid of this. Control-Z, Control-C. That. Let's see what we're doing here, right? What folder am I in? I'm in here. All right. Because I do need to make some changes to this. Okay. So let's open this up in Rider. We're definitely going to overrun today.
That's okay.
That's good, right? We haven't got anything else to do. We're all good.
Oh, I've got lots of other stuff to do, Steve, but I'd much rather be here talking with you and talking with our wonderful audience.
It was my Rider. Okay. Open the directory. Just open the directory.
I'm glad we spent extra time in Beginner's Corner. We were having a lot of really great conversations.
So you'll notice that, well, maybe you won't notice, but here was my original backmask function that was the Lambda function declared, right?
Right.
But what the tooling has done, it's actually created another version of it, the generated version. So at build time, we're using the new C# code generators at compile time to emit this change, right? So what this is saying is, okay, you actually have a function inside here. The handler is generated for me. I don't have to maintain this anymore. Before, I'd have to go in my code. I would have had to, if I changed my function name, I'd have had to gone in here and change this handler to point to it. Not anymore. With the new annotations framework, that's all taken care of for me. All I have to do right now is just take over a couple of these statements, and I could have done this in the code as well. I don't need to do it here, right? I'm going to take into here the role that I'm going to need, right? Come back. There we go. That. Paste this. Okay. I don't know why that's all highlight. No idea why that's all highlight right now. And the other thing that I need is we're using a Lambda layer that's holding the FFmpeg binaries, right? So I need to basically reference that. So here's my layer designation here, right? Why did it do that? That's a weird thing to do. Let me close that off.
You've got code writing code.
Yeah, what's it? Why is it gone yellow? What did it do?
That I don't know. No one can help you there, Steve.
It's horrible. No one can help me. No one can help me. All right, so I'm going to take this layers thing down here.
You know who could help you?
Who could help me?
Justin, but you got rid of Justin, so you're on your own.
Code URI here. I'm just going to bolt in that. I'm going to take these two out because I don't need them. They're in globals. Okay, so that's the Lambda function that was generated. The definition was generated, updated, right? Everything else is the same. Now, one other thing I'm going to do is I'm going to take out this particular. I think it's because I hit Command and Shift K because I'm switching between VS Code and
oh yeah,
Rider. So Rider's using the Visual Studio key bindings. Right. Okay, so now I have my layer definition. I have my function definition. We're all good, apart from I want one more thing, which is some environment variables for that logging setup.
okay.
So I'm just going to paste these in at the top where I have all my globals here. And we'll see why I'm going to use these in a minute. All right. So hopefully relate to Lambda. Okay. So let's see what happens. You can tell I've only recently switched to a Mac, right? My fingers aren't like...
You don't have the muscle memory yet.
I don't have the muscle memory yet. So let's do a SAM build and make sure it builds. Oh, hang on. Where am I? No, I don't want to be there. Oh, I've gone up one too high. There we go. SAM build. I have to be in the folder where the template is, right? We'll build that. What can I say? I'm incompetent.
No, I'm laughing at the comment from Richard. Justin is doing the highlighting
in protest. Yes, yes,
I agree.
All right.
I telepathically made that happen.
It builds. We got that going for us. So let's do the deployment again. All right.
That would be more telekinesis, actually.
I mean, I saved these, but we can just run it now. Let's see if it'll run without being guided. Okay, building, sending.
Waiting for change set.
Waiting for the change set. So this is, if you're not seen this before, this is CloudFormation looking at what you've sent versus what it has to define. Here's the change set of things I need to change, right? And we'll notice straight away. Notice how we now have a new function and a new role. This is the generated wrappers, the generated code in the template versus what I had before, which will clean up. So I'll take that away.
Some code writing code. Code writing code.
And let's face it, the best code you write, the best code you ever run is the code you don't have to write.
That's true. That's very true, unless it's not very good code.
Unless it's not very good code. And we may be about to find that out.
Yeah.
Who knows?
But no, the code that's being generated here is very good code. And I know that because it was created by Norm, right?
Yeah.
Yeah, which
Norm got to deeply go back and consider what we did, right? While we wait for that to go away, right? So we changed this. So instead of taking those horrible types, right, we take the logical thing that we want the function to run on, the query parameter and the body text I want to convert.
Right.
I don't have to take these out of an object type somewhere, right?
No.
By adding the power tools, I can add logging into my code. I don't have to do any explicit storage of the logger object from the context.
Yeah,
right? That's going to be handled for me. And what you'll notice is I'm still emitting here the text, right? Just unstructured text.
Right.
Right. But when we go and look at CloudWatch logs later on, you'll see how that's been converted to a structured statement, a structured logging statement. Lambda annotations requires CloudFormation. I think I read somewhere that the Lambda function requires. I don't know if it does require. I hadn't read that. It does update the template, which is CloudFormation based. So yes, I suspect it probably does. You can't do, I haven't yet tried using our .NET Lambda tools to actually deploy an annotations version of a serverless application without a template. But that's probably something to go try.
To investigate there, yeah.
Investigate.
Can you make, I wanted to ask real quick, Steve, can you make those parameters coming in optional? Like if you don't know if you're going to get a voice ID?
Yes, it is optional.
It is.
Did I not show you that?
I don't know. I don't remember. You may have, and maybe I missed it, which that's very possible.
Here it is. You see this voice ID equals double query. That means if voice override is null or empty, use the default voice constant.
Right? So you don't actually have to set it as optional in the parameter list.
No.
Just when you're trying to use the.
So let's go back to Postman. All right. And let's do, please be so kind to run as to one work.
And
right, we'll just extend this a little bit, right? Some text, right?
Now you have to change the voice ID too.
And now I'm going to change the voice, right? So I think I called that voice override. And let's take Gwyneth, Wales. Lovely. All right.
Okay.
Send
Bye,
that.
Justin.
Fingers crossed. Bye, Justin.
You will be missed. By me only, I assume.
Okay, we have some encoded audio. Woo! All right, so we will take that, and my menu is off screen again. Oh, the perils of a 34-inch wide monitor. It's like it's way over here.
I would love if we could get Megan's voice from the movie Megan. I don't know if you're familiar with Megan.
No, I'm not familiar with half the stuff that you come up with.
It's true. Megan's great. That would be a great voice to have.
These separate. So encoded 2 equals another here string, right? I'm going to post all that new text in, and it looks longer. I'm sure that's not my imagination. All right.
We'll find out.
Decoded 2 equals, let's decode it. Convert, tap. I'm also slow typing today because I got an ouchie last night. I was laying laminate floor and I actually ouchied myself. So,
oh no,
I'm partially crippled today.
I just realized our banner would cover the text, so I was trying to put up a banner, but I'll do it.
What, of my ouchie?
No.
Oh,
welcoming people to the stream, sending them to the GitHub repo where all of this is stored.
So let's call this reversed 2. All right. MP3. So we have 2 files, and it's going to be $decoded 2. And I have to move it down because I don't know why it puts it in the top folder. But anyway,
to help
move it to there. Okay, you ready?
I'm ready.
First, give me 2. Thank you. All right, here we go. Turn the volume up. Now, you probably didn't get the additions to the text, but you should have heard that was a different voice.
It was. That was not Justin.
Right.
What did you just summon, Steve?
I don't know. But what I wanted to show you now to finish up that demo was we're going to go and look into the CloudWatch console, right?
Richard is
question while I do this. Do you know if the cool-looking Power Tools, all of that was .NET Core? So Lambda only runs .NET Core, Richard. So it has to be. I think .NET 3.1 is .NET Core 3.1 is out of support now, but you can use .NET 5. .NET 6 obviously is the latest managed runtime. You could also use .NET 7 if you want, but then you have to build your own custom container image to run it because it's not a runtime support version. All right? So what do you mean I'm running out of time?
No, I said your own runtime.
Oh, your own runtime, yeah. All right, so here's CloudWatch. Let's go into CloudWatch logs. All right. So this is the original function that we ran first thing. Here's the log stream, right? And you'll notice that in the log, that was the message that I sent. Remember, Amazon Polly, please be so kind.
Oh, yeah.
Notice how that's just the string,
right?
Let's go back to the log groups and look at the generated one where I use the Power Tools.
Power Tools.
Right. In the Power Tools now, notice how these are now all structured logs.
Oh, wow.
I didn't change my messages, but I got structured logs out of it. So now I could go to the log insights. I can run SQL queries or SQL-like queries against those logs to pull out various bits of information, right? So that's where that Power Tools library is really, really cool. And it also does metrics and also X-ray if you want to do tracing of the calls, which I didn't do today, obviously, but you can also do that. It's a really simple annotated version that you add. So you got the Lambda annotations framework for converting that grungy Lambda function signature to something more readable, more understandable, especially if you're coming from a dynamic types. And then you have the Power Tools to get like structured logging metrics and other things out.
And if you're not using .NET, you're using other languages. There are the Power Tools.
There are other ones,
other languages like Python, which we used last episode.
So if you want to take a look at the code today, if you're a .NET dev, you want to take a look. If you go to our Code Corner projects repo or AM's Code Corner projects repo.
You almost said Alan Michael.
I nearly said Alan Michael. Yeah.
Who is that?
If I call you Alan Michael, you're in serious trouble.
I'm in trouble.
If you go down to the projects folder, there's an S1E2, Series 1, Episode 2, backmask.net. And that's where you'll find the original code that's in there you can run. And there's also a branch that has the annotations version. It's only using the Lambda annotations framework. It's not using the Power Tools because I wrote this before the Power Tools were released. I only added Power Tools in this morning. But you could then take that and play with it and use the power tools to add X-ray tracing and other things. So a whole lot of fun you can have with that, summoning I don't know what with those messages. But that's C# and Lambda, right?
There you go.
Easy.
I love it. I love it. What an episode. That was just
that was jam-packed, right?
Full of really useful stuff. That's pretty amazing. So Steve, shall we wrap things up?
I think we should wrap it up because we are just over time.
Yes. Yeah. You brought it in just not too far over. So
but it was amazing before we started this one. I was like, how are we going to fill 2 hours?
I know you kept telling me, oh, we're going to do 90 minutes. I was like, okay, sure. Yeah. 90 minutes. Yeah. But look, Steve, we got great comments from everybody watching too. They were very appreciative for the time. So I think it's time well used, at least from my perspective, and hopefully for those of you watching from your perspective too.
And I hope you got from that as well. I mean, there was a little bit of fumbling around in the editing with Ryder, but I hope you got from that how easy it is to go from an existing Lambda function, if you've got one written in .NET, right, to the new annotations version, right? You just add that attribute for Lambda function. You add the HTTP API attribute to say where you want it to be posted. You update your template to remove your existing function definition in the template and adopt the generated one. Right, which just means moving over some permissions and other bits you may have used. In my case, there was a permission and the Lambda layer I was using with the FFmpeg binaries. But other than that, that's all I did. I didn't substantially change my code. Right.
And maybe some of those who were asking us earlier on in the episode, why C#? Why are you showing C# today? Maybe they have a better answer to that question now. Maybe they, stuck with us and saw and are excited to maybe go try out some C#.
Yeah, go try it.
And if not, that's okay too, because we'll cover other languages. Please tell us what languages you all would like to see. We've covered Python so far. C# was today. TypeScript in the future, Golang, more C#, more Python. Whatever you all want to see, please let us know. We saw a bunch of people asking for Rust earlier, so that's got to go on the list, I think, Steve. But yeah, we will be back with more Code Corner in just a few short weeks. If you are curious when we air, we have a schedule on our Twitch page. That's twitch.tv/AWS that has a list of all of our programs, right? So AWS On Air has a bunch of different programs available. We do a Friday show every week where we talk about new launches and new features from AWS. We've got the Startup Show with Jillian Ford. We've got Security Lockdown, which we've got a question that would be a really great question for the Lockdown Show. So Divya, you should go check out the Lockdown Show and ask this question. This is way too deep of a question for the time we've got left today, but we're happy to talk about it too. But definitely go talk to the Lockdown team whenever they have their show going. We got the Game Day show, Step Up Your Game Day. I'm the dev advocate for Game Day, so I got to talk about Game Day. I do. And Steve and I, throughout the year, I think we'll be building a Game Day for .NET, actually, right?
Yeah. Hopefully, fingers crossed.
Yeah. And you might, be able to go play that game at some of the upcoming events that we've got as well. So we'll keep you updated on that. Maybe we'll even talk about what we're building and how we're building on Code Corner too. That could be kind of interesting.
Yeah.
All right. So,
but next episode, I think we should commit at this point to building a class hierarchy for something.
Yeah, that could be a good thing for the beginner's corner. Project
corner will be a class hierarchy of something. I don't know. What should we work in? TypeScript?
I'm feeling TypeScript, but if there's some let us know, right? And you can reach either of us on Twitter as well or LinkedIn. Please feel free to message us if you want to see something specific on the show.
Or drop an issue in our GitHub repo.
Oh, even better. Yeah, please go check out the Git repo. Star it if you feel like it. Whatever you want, right? But yeah, we've got this Git repo to work with you all in here too. All the projects that we'll be building throughout this series will go in this repo. And speaking of, I know we mentioned last time that we would work on adding new features to the backmasking service, which we'll spend maybe a little bit of the Project Corner doing next time, but I really want to get to another project too. So we'll definitely be building something new in next episode's Project Corner. You'll just have to
he just doesn't know. He just, complete transparency, he just doesn't know what yet.
Oh, really? I've got some ideas, but I want to keep it a secret, a mystery.
Yeah.
People come watch. Yeah. Anyway, so we should thank everybody too. Steve.
Yes. Yep.
Thank you all for sticking with us this whole time and watching this whole time.
Hope that was fun.
Yeah, we're getting some Java requests now, which I think is only fair since we spent a whole episode on C#, right?
Yeah.
To cover Java as well. So
that'll be tricky because I've never written a line of Java in my life. But anyway,
I've written some, but not a lot. So we'll see. But yeah, please let us know what you'd like to see in the future. Please let us know, what we can build that will help you. And more importantly, come watch us next week, or not next week, next episode, which should be in 2 weeks.
2 weeks.
Same time, Thursday at 11 a.m. Pacific. Yep. And for older episodes, I sent earlier the link to our Twitch channel. We also have these up on YouTube as well as they come out, but that takes a little bit more time than the Twitch side. On Twitch, they're available almost immediately afterwards. So yeah, go watch episode 1. Anything you want to leave the audience with, Steve?
Go try C#.
Yeah, go try C# and some of our tools.
And take that if you are a beginner program, if you're just getting into coding, and you are looking at strongly typed languages that have things like classes and class hierarchy, go and find something in the house and model it as a class hierarchy. I'm not giving you homework, right? But go do that, because you'll find it quite informative as to when you start thinking through, like we were earlier on, like where certain things would fit in a class hierarchy, right? Yeah. Does it make sense to instantiate classes higher in the hierarchy than maybe the leaf classes in the hierarchy, and so on, right? Go figure that out. Go experiment.
Model some plants.
Obviously, don't model every piece of furniture in the house or whatever it is that you come up
plants.
With.
Model
pick a few bits. Try it out. It's a really good learning experience,
right? Like you can model cactus, get some succulents base class,
right? Plants, pets, furniture, games, right? Pick a favorite game and see if you can model it in a class hierarchy.
Model yourself, Look, Richard loved it, and he'll be back. So hopefully you all will be too. And look, we haven't seen this yet. Ruby. If you want some Ruby. It's been a while since I've looked at Ruby.
No, Ruby. I know we have a Ruby SDK.
Yeah, I've done some Ruby in the past, mostly Rails.
Okay.
Back in the day, Ruby on Rails. But yeah, that would be cool. Ruby was a really nice language, very kind of similar-ish to Python, I'd say, closely related to that. Anyway, we got to wrap up. We got to go.
Yeah.
But thank you all for watching. We will be back for another episode of Code Corner.
2 weeks.
See you then. Bye.
Bye.